And so there's been some incredible changes in technology over the years. Some of you may be familiar with simulation tools. Maybe you've used them in your work. But because of improved compute power today, there's been some incredible advancements in simulation capabilities where we can now simulate different materials from the electronic and the atomic scale all the way up to full components, which is, again, absolutely incredible. But on the experimental side, there's also been some changes in technology that allow us to get more information out of materials and samples today. So for example, in this image here, we're looking at an in situ hot stage XRD scan. So we're actually able to heat up a sample and collect XRD spectra as we're collecting XRD data. And so this is an incredible development that allows us to extract much more information out of our samples and our materials developments today. And what we're really excited about at Lucideon is the interplay between simulation and experimental capabilities. So when you can predict the property of a new material in a simulation, we're really interested in how we can then develop experimental methods to confirm the predictions of those simulations. Now, historically, simulation and experimental capabilities come with some cost. You know, for some simulations, you know, there's a compute cost associated with performing simulations. So quite often it requires supercomputing facilities and high performance computing architectures. And of course, powerful characterization tools are also expensive to operate and run. And so what we're really excited by with machine learning is how we can leverage that tool to structure and interrogate the data that we can extract from simulation and experimental capabilities and drive additional insights and help us to actually make better decisions about which simulations and experiments we ultimately perform. And so this is one of our driving factors for working with Alchemite is understanding how we can use that platform to explore additional patterns and relationships in our experimental data, but to also help us choose the next best experiment.